Welcome to MOVI-C Cabinet and Decentralized VFDs 201. This is Session 10, Decentralized Overview. I want to congratulate you for reaching this point in the class. We're now at the halfway point. We've completed our survey of the cabinet products and we've done a number of labs to explore how they work. We're now shifting gears and we're going to be looking at the decentralized products and doing a series of labs to explore them. As you'll discover, there isn't actually a whole lot of difference, which underscores the point I made right at the beginning of this class that MOVI-C is a highly consistent portfolio of products. As you learn one, the others tend to make sense because they work more or less the same way. So let's dive in and take a look at the decentralized products. Now you probably remember our big drink when we surveyed the cabinet products. Well, you're in for another big drink right now. So hang on to your seat. We're going to do a fast survey of the products and their accessories. It will take a little time, but it's worth it. So here we go. Let's look at the MOVI-C decentralized VFDs, see how they differ from the cabinet products, what they're intended to be used for. I'm going to begin on a very important note. The decentralized VFDs behave very much like MOVI drive technology, and they have similar capabilities and features. They also support the same drive-level MOVI kits. So if you understand the cabinet VFDs, especially MOVI drive technology, you'll have no problem whatsoever transitioning over to the decentralized products. The decentralized VFDs are a little different from the cabinet VFDs in how we approach them. If you remember from Session 2 when we looked at the cabinet VFDs, we saw that they became progressively more powerful and complex as you work through them. That is not true of the decentralized VFDs. They're all approximately equally powerful. Instead, they divide into categories aimed at specific applications. They have roughly the same capabilities, but they're aimed at different kinds of settings. The main decentralized VFDs divide into 4 branches. Let's go over these. The first is called MOVI-C Advanced. This is a VFD paired with either an asynchronous motor like our DRN motors or a VFD paired with an internal permanent magnet motor like our DR2C motor. This gives you a nice all-in-one package with the VFD parked right on top of the motor. It's a very neat, compact way of handling decentralized applications. Next, we come to something similar, MOVI-C Performance. This is a VFD paired with a servo motor, a synchronous permanent magnet motor. We then come to something a little different. We come to MOVI-C Flexible. MOVI-C Flexible does not come with a motor. It's meant to be used with a motor that you supply. It's typically connected up by a short cable, so it's mounted nearby. This will work with a wide variety of motors, both SEW Eurodrive motors and third-party motors. That's why we call it MOVI-C Flexible. And then finally, we come to a rather specialized product, the MOVI-Gear Performance. This is a combination of 3 products. It's got a VFD, a high-efficiency servo motor, and a high-efficiency helical gearbox. We need to go on a little tangent here because MOVI-C Flexible comes in 3 different variants, so there are 3 forms of it. The first one is called MOVI-C Flexible number 1, MMF1. It's essentially just a base with some connectors, so it's a very bare bones kind of version of MOVI-C Flexible. MOVI-C Flexible number 3 is a little more elaborate. It has a base with connectors, a place to mount a keypad, a disconnect switch, and a manual mode key. So this is a little more deluxe. And then we have a specialized version called the Logistics version. This looks sort of like MMF3, but you notice it doesn't have a place for the keypad. It's a base with connectors. It has a manual mode key, a direction selection switch, and some extra I/O. This is aimed at the logistics industry and its specialized needs. You can see MOVI-C Flexible is indeed very flexible. MOVI Pro technology is a rather unusual decentralized VFD. I think of it more as a hybrid VFD. It is decentralized. It's meant to be used out in the environment near the application, but it's got a MOVI drive technology inside it. It's almost like a decentralized cabinet with a cabinet VFD within. And then MOVI-C Performance ELV is even more specialized. This is a low voltage version of the MOVI-C. It runs on 48 volts DC. It's a VFD combined with a motor and with an optional gearbox. Now in this class, we're going to focus on the field bus controlled version of the MOVI-C flexible VFD. We're going to be using MMF1, which is the rather bare bones version, just the VFD with a simple base. Be aware, however, that almost everything you learn about it applies to the other field bus controlled decentralized VFDs. We're not going to be discussing MOVI Pro Technology or MOVI-C Performance ELV. These are aimed at specialized applications. MOVI-C Flexible gives you a very broad view of many application possibilities, and it works very similarly to the other four main branches of the decentralized portfolio, so it's a good choice. The heart of most MOVI-C decentralized VFDs is the electronics cover or E-cover. It's this component. It's either parked on top of the motor, or in the case of MOVI-C Flexible, it's parked on top of the base. This contains really everything. It contains the VFD itself, its communication system. There's very little in the base other than some connectors, so think of the E-cover as the VFD. An important point to remember is that E-covers are interchangeable among different products subject to a few rules. In other words, you could take the E-cover off a MOVI-C Flexible and put it on a MOVI Gear Performance as long as you meet these rules. What are these, you might ask? Well, let me give you two of them right up front. First of all, number one, it has to physically fit. That's common sense. And secondly, it has to be of a compatible power rating with the device you're putting it on. That's not too complicated. We'll talk about the third rule in just a few minutes. The E-cover attaches to the terminal base, which contains the wiring and some connectors and some minor circuitry. You can see the terminal base is here. On a MOVI-C Flexible, the terminal base is a little more elaborate than it is on the motor-mounted versions, but it's the same basic idea. And here's the third rule for mixing and matching the E-covers. The base itself, of course, must physically fit, and it must be compatible with the E-cover's communication and control type. We'll get into that in just a few minutes, but as long as you have something that physically fits, has the right power rating, and has a compatible communication and control type, you can mix and match those covers freely. And I'm sure the maintenance people will be very happy to hear that. Let's take a quick look at the IP ratings of the decentralized products. As you can see, they are definitely higher than the cabinet products. They do vary considerably, so be sure you're aware of what the product's limitations are before you put it in an environment that is unusually wet, dusty, or dirty. Also, I'm going to add just as a warning, to maintain the IP rating, always follow the manual's guidelines for properly torquing the 4 bolts on top of the E-cover. There is a specific torque and also a specific pattern for torquing them down. I will also recommend that you always replace the gasket, especially if the E-cover has been closed up for a long time. The gasket tends to develop a memory when it's compressed, and it won't seal as well the second time. Replacing the gasket is a very inexpensive way of ensuring that your IP rating is what it ought to be. MOVI Pro Technology and MOVI-C Performance ELV also have IP ratings that vary, so again, I recommend you be sure that they will meet what your application requires. And time for a warning. The E-covers contain capacitors that can hold a high voltage charge for a period of time after the power is disconnected. According to our documentation, you should always wait a minimum of 5 minutes before removing the E-cover from the terminal base. If you take it off sooner and touch the wrong thing, you could be very sorry. So be careful. You have been warned. Let's look at the E-cover facts very briefly. First of all, notice that they do not operate on lower industrial voltages like 230 volts. They are intended to be operated between 380 and 500 volts, 3-phase AC. They do come in 4 sizes with multiple ratings up to 16 amps. They have built-in safe torque off capability, which we talked about earlier in this class. They come in 4 control styles and have 5 possible field bus types, so a lot of flexibility here. They include a MOVI-Link DDI interface, so they will work with our MOVI-Link DDI motors. They accept keypads if you wish to control them with a keypad. They have between 4 to 7 digital inputs depending on the model. and 2 digital input-outputs. These are signals that can be configured to be either an input or an output. Some models come with a relay, and some models come with an analog input. E-covers come in 4 sizes, which you can see here: size 1, 1E, 2, and 2E. You notice that as they get bigger, they have more aggressive heat sinking on top, and the size 2E includes a fan as well. They do come in multiple current ratings per physical size, so there will be several E-covers within each size as far as ratings. E-covers come in 4 different communication and control styles, which I'm going to go over right now. Remember, I said that when you mix and match, the base has to match the control style. The first control style is the DBC E-cover. That stands for Direct Binary Communication. This E-cover is meant to be controlled by digital signals. It also has a speed control potentiometer built into the cover. This is used for very simple systems where you just use signals to control it, and that is all. Then we have the DAC E-cover, which stands for Direct ASI Communication, ASI, Actuator Sensor Interface. This is a very simple kind of field bus. The DSI E-cover stands for Direct System Bus Interface. This has the SEW Eurodrive S-Bus Plus field bus built into it. Remember, that's based on EtherCAT. We talked about that several sessions ago. And then lastly, we have the DFC E-cover, which stands for Direct Field Bus Communication. This uses one of several industry standard Ethernet-based field buses, and you can pick this when you order it. The DBC and the DAC E-covers share a common terminal base type, as do the DFC and DSI E-covers. You can mix and match DSI and DFC E-covers on a device with a base that matches them. You can mix and match the DAC and the DBC on a base that matches them. Let's talk about control. If you've got a DBC, the Direct Binary Communication E-cover, you can operate it one of 3 ways. You can use a keypad, you can use switches and potentiometers, or you can use digital I/O signals from a PLC or other industrial controller. If you have the DAC E-cover, Direct ASI Communication, then you will connect this up to an ASI field bus. ASI is very simple. It's essentially binary control over a field bus. Usually you have a PLC talking to an ASI gateway, which in turn talks to the field bus. You can control this E-cover with a keypad, with switches, or a PLC over an ASI network. The DFC E-cover is very popular, Direct Field Bus Communication. You can see the field bus types that are available: Ethernet IP, Modbus TCP, Profinet, and Ethernet PowerLink. Normally you would connect these up to a field bus, and a PLC would then send it commands over the field bus. However, you can also control it by a keypad or switches as well. And the Direct System Bus Interface E-cover, DSI, could be connected up to an SEW Eurodrive controller of some kind. We have a field controller right here. Another possibility is to use a third-party PLC that has EtherCAT capability. There are a number of brands that do this. And a third choice is to use a highly specialized kind of controller called the CIA 402 controller. This is used in some industries, and if you have a DSI E-cover, it can talk to these, but you will have to order a special firmware at order time. Of course, you can also use a keypad or switches to control a DSI E-cover. The MOVI-C decentralized VFDs support the same 4 motor control modes as the cabinet VFDs. Of course, if you have a decentralized E-cover paired with a specific motor, then it's only going to be able to use modes that work with that particular motor. But if you have a MOVI-Mod Flexible, which is connected up to a motor of your choice, all 4 of these modes will be available. The decentralized products really like SEW Eurodrive's MOVI-Link DDI motors. Remember, the DDI motor supports things like electronic labels, encoder data, thermal data, and sensor data all over that single hybrid cable. If you have a DDI motor, it will pair very nicely with the decentralized VFDs. And in fact, if you want to use an encoder with your VFD, the only type of encoder that is supported is the MOVI-Link DDI type encoder. Now it's time for a little warning. This applies to all MOVI-C VFDs when they're paired up with the MOVI-Link DDI motor. We want you to be aware that when you factory reset a VFD connected to a MOVI-Link DDI motor, you need to be rather cautious. MOVI-Link DDI motors commission themselves automatically, and depending on what's connected to the VFD's digital inputs, they can start running immediately after a factory reset. If you have something connected to the wrong digital input and it's turned on, that could trigger the motor into operation. Now we have changed this behavior in firmware version 13 and higher, so this will not happen in those firmwares. But if you have an older firmware, this is a possibility. So we're letting you know, in the interest of safety, always be sure that that motor can't do any harm if it should start turning when you factory reset the VFD. And if it could, find some way to immobilize it before doing that. Okay, you've been warned. The e-covers have a nifty feature in them that makes rapid replacement and restoration simple. They have a removable memory module. This is sort of like what was found in the MOVI-Drive technology, which we talked about a while ago. You can swap this to a new e-cover if something goes wrong, and it carries all the commissioning with it, all the parameters, and any MOVI kits installed. Incidentally, if you're wondering about the dip switches on it, these are normally not used with a MOVI-Link DDI motor installation, but if you're using this with a non-MOVI-Link DDI motor, the dip switches are used for some configuration settings. Useful to know. How do the decentralized VFDs report their status? Well, those with e-covers use a number of different colored lights on them, so there is an LED status panel. And by looking at the colors and the flash patterns, you can figure out what's going on. The first two indicators tell you what the VFD is doing as it relates to its own internal controller. The fourth location indicates what the VFD is doing as far as the motor. So when the motor's running, this light will change to a specific color. By the way, the black dot in the third position is not an LED, it's just a black dot, so you can ignore that. The next two indicators are field bus specific, so depending on what kind of field bus you have, these will be meaningful in different ways. This e-cover is an Ethernet IP and Modbus TCP cover, so the lights indicate things pertaining to that field bus style. And then the last two lights indicate the field bus connectivity status, so they tell you if you're connected to a field bus and if the field bus is communicating. I refer you to the manual to interpret the colors and the patterns. There are far too many to talk about here, unfortunately. Let me show you, though, a common pattern that would indicate everything is good. If you see green lights on the first 5 LEDs and yellow on the last 2, that is telling you that everything's well with the VFD and its controller. The motor is turning, the field bus is connected, and it's communicating. So that's good. Let's talk about connectors for a second. There are many possible connector combinations between the terminal base, the e-cover, the motor, and external accessories and control sources. We cannot go over all of them here. We'd be here for hours and you would fall asleep. So I'm going to illustrate some common examples just to illustrate what you might see, but I am going to have to point you to the manual for the specific details. There are just too many to talk about otherwise. All right, if you have a DBC or DAC e-cover, the connectors are relatively simple. There will be 2 speed control potentiometers under protective covers. The connector allows you to connect up a potentiometer or analog signal source to control it. Now, if you have the DAC e-cover, that connector will be for the OSI field bus instead. So very simple cover for those two. If you have a DFC or DSI, however, you have more possibilities and definitely more connectors. I'm showing you a version that comes completely connectorized. All the I/O signals are brought out on M12 connectors, and also field bus in and out comes out on a pair of M12 connectors. You can buy this one. You'll have all your connectors brought to the outside, but we do sell a version that has just the I/O signals and not the field bus connections, and there's also a cover with nothing brought to the outside. Now you may wonder, how do I make connections then if I get the nothing cover? Well, you won't be able to connect to the I/Os. This would be an application you don't need I/O. But internally within the box, you will find field bus connections. So there are always field bus connections, either internally or externally. The terminal base itself varies depending on which e-cover it combines with. I'm going to show you a DFC and DSI terminal base. It has a connector that mates up with the E-cover. There's a place to connect your power in, your line in, your three phases. There are protective earth connections. There's one here and there's one down below which you can't see in this picture. The motor connects up here along with its brake and temperature sensors. The brake resistor connects here. This block provides for safe torque off connections, and right now it's got a jumper block there which keeps safe torque off from inhibiting the motor. There's also a MOVI-Link DDI connection here, an engineering port, and these are the internal field bus connections. So if you don't have them brought out on the outside cover, you can connect to these internally. However, remember, some E-covers and bases can have the field bus, the engineering port, and the MOVI-Link DDI connectors brought to the outside. Again, it just depends on the configuration. The DBC and DAC terminal base is similar, but it will not have all these connections because those covers do operate a little differently. An important note here. The E-covers do not have a controller inhibit signal, DI00, brought out to a connector. There is no way to connect a signal to controller inhibit. The signal is internally set to always be on, so the VFD is never inhibited. This is different from the cabinet VFDs. And you may be thinking, okay, well, what if I want to inhibit my VFD for safety reasons or to work on it? How can I do that with a digital signal? The only way to do that is through the safe torque off connector. You could wire that up to something to control it, but there is no controller inhibit signal that you can turn on and off. You will see it when you're operating in MOVI-Suite, but it will always be on. The terminal base connectors come in many different styles depending what you wish to order. For example, I'm showing a terminal base with an external engineering port that can be connected to the USM21A using the M12 to USM21A cable, which I show here. I also show a base that has lots of knockouts for additional connectors, and it has a MOVI-Link DDI hybrid cable connection. So this is just one example, but there are many. What about options and accessories? What can you get with the decentralized products? Lots of different things. For example, you can get controllers of many types. We call these our field controllers. They're very much like the cabinet controllers, but they're in an environmentally hardened enclosure so they can be out in the decentralized environment. They work very much like our cabinet controllers, and they too are rated by the number of axes they control. One important side note, if you have a DSI E-cover, you can pair it up with an SEW Eurodrive controller and run controller-level MOVI kits on it. This is a departure from the general principle that the decentralized products run drive-level MOVI kits. They certainly do, but with the DSI E-cover you can also do controller-level. All the keypads, which we've already covered, so we won't talk about them again, do work with the decentralized products. And again, you can use them to engineer the VFDs, get status information, diagnostics, do backups, and of course you can use the mini USB interface as an engineering adapter for a decentralized VFD. The CBM22A allows you to connect a keypad up to a decentralized VFD through a cable. That can be rather handy in some applications where the keypad should be mounted somewhere else rather than directly on the VFD. And now we have just one miscellaneous point to go over. There is a version of the MOVI gear that does not come with the VFD. We call it MOVI Gear Classic. You notice the top is a little shorter because it doesn't have the VFD parked on there. This version of the MOVI gear, which has a high efficiency motor and gearbox, can be controlled by a cabinet VFD, or you can pair it up with one of our decentralized VFDs like a MOVI-Mot Flexible. And then finally, documentation. There are a lot of manuals because there will be a manual for each E-cover style, and there are 4 different major branches of the decentralized products, so that's 16 manuals total for those. Of course, MOVI Pro Technology has its own manual set. The ELV MOVI-Mots have their own manual sets as well, so there are actually quite a few manuals. I point you to SEWEurodrive.com as the right place to download them. And that's the end of our big drink. Good job. Nice work. Thank you for hanging in there. And that ends our session. In our next session, we're going to go into a lab with our decentralized MOVI-C Flexible. We're going to configure it using the keypad, which is an interesting and different way to work with it.